I wish you a very happy birthday to the students who are celebrating their birthday today. Before watching the class, my sincere request is grab a notebook and a pen to take notes from our videos. Believe me, it helps a lot in the process of learning. Have you ever questioned yourself which is responsible to do some activities like what do you do to make a football move? What do you do to stop a moving ball? How does a bowler throws a ball? How a batsman hits the ball? How the fielders stop the ball? How do you stretch a rubber band? What do you do to take out a book from shelf or a bag? How a mother make chapati from ball of dough? In all these situations, the objects made to move from rest or move faster or make a stop and changes their direction of motion and change their shape. In ancient days, people thought that an invisible thing exists for the changes around us, like changes in seasons, changes during sunrise and sunset, changes in the tides of sea, etc. The invisible thing that is responsible for all these actions is force. In this all about discussed situations, we often say that a force has been applied. So let's see what is a force. In simple terms, force is a push or pull on an object. Actions like picking, kicking, lifting, hitting, lowering, squeezing, stretching, compressing, opening and shutting, twisting can be classified as pull and push. Let's classify the following activities as push or pull or both. Opening or shutting a door comes under push and pull also. Drawing a bucket of water from a well, it is purely a pull. A football player taking a penalty kick, it is a push. Moving a loaded cart, you can either pull it or push it in order to move. Opening a drawer, it is a pull. Erasing blackboard, here also pull and push are involved. A cricket ball hit by a batsman, it is also a push. Digging a bowel, here a push and pull are involved. Sipping juice with a straw, purely it is a pull. A magnet attracting nails, it is a pull. If the same magnet repels another magnet, then that is a push, remember. Fruits falling from tree, it is a pull. Hoisting a flag, it's a pull. Let's go to our whiteboard to discuss few more points about force. So force is denoted by a letter F, children. Okay. So you might have learnt in your 6th class that mass is denoted by letter M, length is denoted by letter L, time is denoted by letter T. Clear? Similarly, force is denoted by letter F. Nana. Now let's see what are the units of force. You might have learnt in your 6th class the unit of mass is kilogram in MKS system. Did you remember? And gram in the CGS system. Did you remember, children? Similarly, length unit is meter and centimeter in CGS. Time unit is same, second and second in CGS MKS. Got it? Similarly, what are the units of force in MKS system and CGS system? That's what we are going to learn now. So first let's discuss what is the MKS unit of force. The MKS unit of force is kilogram meter by second square. Listen carefully how I am reading it. kilogram meter by second square, or you can read it as kilogram meter per second square also. Similarly, CGS unit is gram centimeter per second square. Clear? Very simple. MKS unit is kilogram meter by second square. CGS unit is gram centimeter per second square. Or you can call this gram centimeter per second square as dyne also, children. A short name. Feel that as a short name. Instead of saying gram centimeter per second square, simply you can say as dyne. Similarly, we have a name for kilogram meter per second square also, that is Newton, a scientist name. Okay, simply you can write MKS unit as a Newton also. Actually this is a SI unit. Okay, so remember in that way. So hope you are clear what is the MKS unit, what is the CGS unit, and what is the SI unit of force. Be careful while you are writing SI unit. Okay, you should write small letters, all small letters if you want to write full name, or if you want to write a symbol, just you write a capital letter, that's all. Okay, so don't write in this way Newton as NEWTON or Newton symbol as small letter. These two are wrong methods of writing units. So if you want to write full name, use all small letters. If you want to show symbol, just use capital letters, children. Clear? Now let's discuss about the conversion of units from MKS system to CGS system. Like 1 meter is equal to 100 centimeters, you might have learnt, right? 1 kilogram is equal to 1000 grams, isn't it? This you learnt in your class 6 and 7. Similarly, here also we are going to convert unit of force from MKS unit to CGS unit. Clear? So, what is the MKS unit of force, children? Kilogram meter by second square. Simple. What is the CGS unit? Gram centimeter by second square. So, now we are converting 1 kilogram meter by second square is equal to dash gram centimeter per second square. Okay. Very simple here. You are converting kilograms into grams and you are converting meters into centimeters. That's all. So, use the values from here. 1 kilogram is how many grams, my dear? 1000 grams into meter is how many centimeters, my dear? 100 centimeters divided by here and here you have same unit, so you no need to convert it as second square. This can be written as 1 into 1000 can be written as 10 power 3 grams into 100 can be written as 10 power 2 centimeters by second square. So, in mathematics you might have learned when bases are equal, powers to be added. Clear? So, this 3 and 2 can be added and you can write finally 1 into 10 power 5 gram centimeter by second square. Understood? Therefore, 1 kilogram meter by second square is equal to how much, children? 10 to the power 5 gram centimeter by second square. Can I write this as 1 Newton? This kilogram meter by second square as 1 Newton? Yes, okay, which is equal to 10 to the power 5. What can I write this? Gram centimeter by second square? Very good, which is dyne. So, in this way also you can write 1 Newton is equal to how much, my dear? 10 power 5 dyne. And see the inverse of this. So, I can write this as 10 power 1 by 10 power 5 Newton is equal to 1 dyne. Okay. So, 10 power minus 5 Newton is equal to 1 dyne. Clear? So, when numerator comes up, this power will become negative. So, using this you can convert from MKS unit to CGS unit or CGS unit to MKS unit. Hope you understood, children. Okay. Now, let us solve few numericals based on this so that you will be getting perfect in this. Okay, first question. 250 Newton is equal to dash dyne, my dear. 250 Newton is equal to dash dyne. Right. So 250 Newton can be written as 250 into 1 Newton. Okay. When you multiply this 250 with 1, it gives 250. So its value doesn't change. So write 250 as 250 into 1 Newton is how many dyne? 1 Newton is 10 power 5 dyne. Just now we learnt. So just substitute that value, 10 to the power 5 dyne. Therefore, what is your answer, my dear? 250 into 10 power 5 dyne. Or you can write this as a 25 into 10 power, this 0 will be added here. So 10 power 6 dyne also. Hope you understood. Now let us see second question. 10 power minus 8 dyne is equal to dash Newton. Suppose it is given in your book. Then how to convert this? So write 10 power minus 8 dyne as 10 power minus 8 into 1 dyne. So which is equal to 10 power minus 8 times 1 dyne is how many Newton? You know that 1 dyne is 10 power minus 5 Newton. So substitute that 10 power minus 5 Newton, which is equal to 10 power. What you have to do? You have to add the powers. So minus 13 Newton. That's your answer. Let's see one more question finally. 0.002 into 10 power minus 3 Newton is dash dyne, my dear. Okay, see this. So 0.002 into 10 power minus 3 into Newton. We are converting Newton into dyne. We know that 1 Newton is 10 power 5 dyne. Simple. So which is equal to 0.002 into 10 power minus 3 plus 2, which is plus 2 dyne. Clear? Further, you can write this as 0.2 dyne. Clear, children? Very good. Now you take some numericals as your homework. Copy these in your notebook and you can practice it later. Hope you copied this. Very good. Let's discuss one more important point, my dear. So whenever you write force is equal to 5 Newton, okay, it can be 5 or 10 or whatever it may be. So whenever you write force as something, you add direction to that, my dear. So force equal to 5 Newton east. What does it mean? It means that you are applying force on an object in the direction of east. Okay, how much? 5 Newton. Simple. Whenever you write force, mention direction also. It's very important. Clear? So I think you know the directions on the paper. This is east, west, north and south. Clear, children? Okay, for example, I have written force is equal to 15 Newton north. Then how my force is acting on the body? If this is the object, okay, my force is towards north. Either you can draw in this way or what is the other way? This is the object and you can draw force of 50 Newton in this direction. Both are correct. Clear? For example, I have written force is equal to 20 Newton west. Then how you have to draw that or how you have to understand it? There is a body. On this body, force is acting in the direction of west. How much force? 20 Newton. So remember, whenever you are writing force, write magnitude with the direction. Clear, children? Don't forget to mention the direction of force. It's very important one. So this is about today's class. Hope you enjoyed the class. We will meet you in the next class. Bye bye.